All right, you guys, I'm going to do a really short video on 9.1 for the conics. This is just a review of really Algebra 2 and pre-calculus. So we're going to do parametric, and then we're going to do the calculus part of parametric. So in terms of graphing parametric, the conic section can be helpful because a lot of times what we draw are parabolas, maybe ellipses, hyperbolas, etc. So let's just kind of run through it. I'm going to run through some of the homework questions. I'm going to try to just touch on one of each, and that should be sufficient. We're going to forego all of the, like the focus, the directrix, all that stuff. That's not really that important for what we're doing right now. Okay, so for the parabolas, you've got here, we're looking at x squared, so it's going to go up or down. Here is the y squared, so it's going to go left or right, and then the hk is going to be your vertex, and that's kind of what we're going to focus on. So the first one I have is number 5, which is just y squared equals negative 8x. So things that you want to focus on are it's y squared, so it's going to go left or right because there is a negative, and the negative can be on either side. It's going to be opening to the left. So the vertex here is 0, 0, because there is nothing. It would be like this, which we would never write it like this, but y minus 0 squared, negative 8x minus 0. So it's 0, 0, and then you could pick any point. I like to pick for the squared term. So actually, I would actually pick for the y here. So if y was 1, x would be negative 1/8. So it would maybe look something like that. And I know that it's going to open left, so it would look like that. Okay. Let's do a completing the square one, and then we'll jump to the ellipses. So number 9 is x squared plus 4x plus 4y minus 4 equals 0. So we're going to complete the square for the x term. So I'm going to bring over the y's. So you get x squared plus 4x, and then we get negative 4y plus 4. I take half of the middle term. So it's going to be half of 4, which is 2 squared. So we add 4 over here. This gives us x plus 2 squared. And then this becomes negative 4y plus 8. And I'm just going to take out the negative 4. So you get x plus 2 squared. You get negative 4, and then y minus 2. So the vertex here would be negative 2, 2. Negative 2, 2. It's going to open left. And again, I'm not going to do the focus or the directrix. Remember, this was the 4p value. So we could say negative 4 equals 4p. P equals negative 1, which would be the distance you move. The focus is on the inside, directrix on the outside. Focus is a point, directrix is a line, but we're not going to do that. I'm going to simply make the graph here. So we've got, let's see, negative 2, 2. And then again, it's going to go upside down. I'm not going to pick points right now, but to pick a point, again, I like to pick for the squared term. So actually, in this case, I would pick for the x. I might even just pick the y-intercept here. So maybe pick, if x is 0, then you can come up with the y value. So that means we'd get 4y minus 4 equals 0. And you get y equals 1. Yeah. So my graph is definitely not drawn to scale, but that's how I would probably go about picking the points for this. All right, so the next is going to be the ellipse. So ellipse is probably the easier of all the conics. So xh is going to be your center. Let's see, so A is always the bigger one in the ellipse. So that kind of just dictates how the graph will show up. So for example, if the A is under the X, it just means it's going to be longer on the X axis. If the A is under the Y, it's going to be longer on the Y axis. Okay, so it doesn't really matter which one is first. In the hyperbola, it does matter. So if you want to just memorize where A is always first, that is fine. Because then this would come over here, right? But then it would be on the y-axis. This would be longer. So this would be longer on the y, this would be longer on the x, okay? All right, so let's do an example of the ellipse. I'm actually just going to do a completing the square one. That will cover all aspects of it. So this is number 33, I believe. So it's 9x squared, and then plus 4y squared, plus 36x, minus 24y, plus 36 equals 0. So for this, you're going to complete the square for each of the x's, for the x squared, and then for the y squared. So it's almost like you have two mini problems in one here. So we've got 9x squared. We can collect the x's, and then plus 4y squared equals negative 36. So remember, to complete the square, you want to make sure that the square term has a 1 in the front. So it's going to be 9 and then x squared plus 4x plus 4, and then we get y squared minus 6y equals negative 36. So we complete the square. Half of the middle term is 2. 2 squared is 4. So I'm not just adding 4, I'm actually adding 4 times 9, which is 36. So we're going to come over here at the 36. Half of negative 6 is negative 3 squared, so I'm adding 9 times the 4 is another 36. So we're going to get 9 and then x plus 2 squared plus 4, y minus 3 squared equals 36. We want to make sure that that equals a 1 over here, so divide out the 36. So we're going to get x plus 2 squared over 4, and then y minus 3 squared over 9 equals 1. So my center here is going to be negative 2, 3. And then, so this is how I like to just, because there's a lot to memorize between the ellipses and the hyperbolas. For me, since the 9 is the bigger number and it's under the y, it's going to be longer on the y-axis. Okay, and again, that seems to work. So I'm going to do negative 2, 3 as my center. So negative 2, 1, 2, 3. Now, this is your a squared is 9. So a is plus or minus 3. So a is going to be the distance you go out on that axis. So it's on the major axis because a is bigger, but I'm going to go out the 3 units. So up 3, down 3. And then, so b squared is 4. So b is plus or minus 2. So that means I go out left and right too, which you can see where here it becomes bigger on, or longer on the y-axis. Okay, so that's the ellipse. And lastly is going to be the hyperbola. So let me come back up here with the hyperbola. So similar to the ellipse, right? Except this has a plus, this has a minus. So that is the big difference between the ellipse and the hyperbola. They're both squared, but the difference here is a is always the first term. So a is always first. So whatever first dictates which axis you draw it on. So regardless of size of the a, so a could be bigger or smaller. So this just means this is going to be drawn on the x-axis. So it's going to look like that. And then this means because it's first, it's going to be drawn on the y-axis. Okay? So let me just do one hyperbola. So let me do the completing the square one because that one sort of just encompasses everything, and then we'll be done with this video. So I'll do number 41. So 41 is 9x squared minus y squared minus 36x plus 6y plus 18 equals 0. So same idea as the ellipse. But again, you really truly don't know until you finish completing the square, but this looks like it's going to be a hyperbola because the x squared is positive and the y squared is negative. All right, so I'm going to collect my like terms. So we're going to get 9x squared minus 36x, and then minus y squared plus 6y equals negative 18. So same idea, we can't complete the square until we get the x squared or the y squared to be a 1. So take out the 9, you get x squared minus 4x, and then I'm going to take out a negative here. So think of it as a negative 1. So we get y squared minus 6y, and then negative 18. Half of negative 4 is negative 2. So I'm adding 4, but plus 9, and not plus 9, so 4 times 9, which is 36. So I'm adding 36. And then this one is plus negative 3 squared, so it's plus 9 minus 1, you get negative 9 minus 9. So we get 9, and then x minus 2 squared, y minus 3 squared. So 18 minus 9, which is 9, like that. And then again, we want to get this to be a 1. So divide out the 9, 9, and 9. So we get x minus 2 squared over 1. Y minus 3 squared over 9 equals 1. So we don't rearrange it, okay? We want the minus to be in the middle, and whichever one is first is the axis we draw it on. So this is going to be on the x-axis, okay? So it's going to look like a sideways parabola, or two sideways parabolas. Okay, so this is here, this is here. So my center is, I just realized the mistake. I took out a negative 1. This should be a positive. So this is a positive. I don't think it affects over here because I squared it, so that's fine. So my center is actually 2, negative 3. So 2, negative 3, like that. And then you can draw the asymptote, I guess. I don't know the best way to do this for what we're doing right now. There's different, there's a slope formula to get the asymptotes, so we could do that. That's kind of how I do this. So we can say a squared is 1, so a is plus or minus 1, and then b squared is 9, b is plus or minus 3. So when we write the equation of the asymptote, which we're not have to do that right now, but it goes through the point, so they would go through the center. But the slope, it's either going to be a ratio of a to b or b to a. So it depends, okay? If it's vertical, so if it's on the y-axis, it is a to b. And then if it's horizontal on the x-axis, it's b to a. So this is going to b to a, which is 3 to 1. So my slope is 3 to 1. So you could do it one of two ways. I like to just count up 3 over 1, up 3 over 1, like that. So up 3 over 1, up 3 left 1, down 3 right 1, like that. And that sort of creates these asymptotes, which helps us graph it, okay? And then the a value is the distance you're going to go out on whatever this is, so on the x-axis. So I'm going to go out 1, and then we just draw it like that, okay? All right, so that's just a quick summary of the conic section. Not that it's not important. It's a little bit. It will help you a little bit when we graph some of these parametric functions. So I hope this helped. Let me know if you have any questions.